Hello viewers, welcome to my channel AK Concepts of Electrical Engineering. Wave propagation in free space. In free space, epsilon equals to epsilon naught and mu equals to mu naught. Travels electromagnetic wave propagation in x direction that the dou square Ey by dou t square is equals to 1 by mu naught epsilon naught dou square Ey by dou x square. Ey may vary sinusoidally or cosinusoidally. Then let Ey equals to E naught cos omega t plus j sin omega t, where E naught is the peak value and omega is the angular frequency. Ey equals to E naught cos omega t or Ey equals to E naught sin omega t. We have that cos omega t plus j sin omega t equals to e power j omega t. We can write this as Ey equals to E naught e to the power of j omega t. Differentiating with respect to t, dou Ey by dou t equals to E naught e j omega t with respect to t, so j omega. Again differentiating with respect to t, then dou square E y by dou t square is equals to E naught j omega. Then if you do this, E j omega t j omega. This will write as E naught j square omega square e to the power of j omega t. And we know that j square is nothing but minus 1, or j is nothing but square root of minus 1. So this equals to minus omega square E naught e to the power of j omega t. E naught j omega t, which is nothing but Ey from the equation number 1. Dou square Ey by dou t square equals to minus omega square Ey. Let this be A. When you compare equation A with this equation, you are going to get left hand side both are equal. So 1 by mu naught epsilon naught dou square Ey by dou x square equals to minus omega square Ey, from which dou square Ey by dou x square equals to minus omega square mu naught epsilon naught Ey. Usually the operator dou by dou x is denoted by d. Dou square by dou x square equals to d square. Then this one is d square Ey omega square mu naught epsilon naught Ey equals to 0. And this you can write, take Ey common, then d square plus omega square mu naught epsilon naught equals to 0. Ey of d square plus omega square mu naught epsilon naught equals to 0. That is equation B. Now in this equation Ey is not equals to 0, then d square plus omega square mu naught epsilon naught equals to 0. Then you can write this as d square is equals to minus omega square mu naught epsilon naught. D equals to square root of minus omega square mu naught epsilon naught. So omega square is this under the square root. I'm taking this out. Omega minus 1. So minus 1 is nothing but, before we have seen that j square equals to minus 1, then j equals to square root of minus 1. J coming out square root of omega naught epsilon naught, plus or minus. Plus or minus. And the solution for this partial equation, that dou square Ey by dou x square equals to minus omega square mu naught epsilon naught Ey, takes the form that Ey equals to k1 e to the power of j omega mu naught epsilon naught of x plus k2 e to the power of minus j omega mu naught epsilon naught of x, where k1, k2 are constants with respect to x, but they may be the functions of t. Let k1 equals to e1 e to the power of j omega t and k2 equals to e2 e to the power of j omega t. Now assume that k1 k2 are cosinusoidal. Now substituting these values of k1 and k2 in the equation number 2, we will get ey equals to e1 e to the power of j omega t multiplied by e to the power of j omega square root of mu naught epsilon naught of x plus e2 e to the power of j omega t e to the power of j omega square root of mu naught epsilon naught of x, and this is a negative. Let omega square root of mu naught epsilon naught equals to beta, then this equation will write this as ey equals to e1 e to the power of j omega t e to the power of j beta x plus e2 into e to the power of j omega t e to the power of minus j beta x. You can write this as e1 e to the power of, take that j out, then omega t plus beta x plus e2 e to the power of j omega t minus beta x. Now, if we expand this, ey equals to e1 of cos omega t plus beta x plus j sin omega t plus beta x plus e2 into cos omega t minus beta x plus j sin omega t minus beta x. Now separate the real and imaginary parts. Then ey equals to, in real parts, e1 cos omega t plus beta x plus, this is imaginary part and this is imaginary part, so e2 cos omega t minus beta x. Similarly, imaginary part of ey equals to e1 sin omega t plus beta x plus e2 sin omega t minus beta x. Consider the wave equation that dou square e y by dou x square equals to mu naught epsilon naught dou square ey by dou t. Now it can be shown that ey equal to sin omega t plus beta x and ey equals to cos omega t plus beta x and ey equals to sin omega t minus beta x and ey equals to cos omega t minus beta x. These are all the solutions for this equation. Now let ey equal to sin omega t plus beta x is the solution. Differentiating this, dou ey by dou x equals to beta cos omega t plus beta x. Now again differentiating this, then you are going to get dou square ey by dou x square is equals to minus beta square sin omega t plus beta x. Sin omega t beta x is nothing but ey. So minus beta square ey equals to dou square ey by dou x square. Now substituting the value of beta, minus beta is omega square root of mu naught epsilon naught whole square ey minus omega square mu naught epsilon naught ey. Differentiate ey with respect to t. Then you are going to get omega cos omega t plus beta x. Then again differentiating this with respect to t, then minus omega square sine omega t plus beta x. Sine omega t beta x is nothing but dy. So minus omega square dy. Dou square dy by dou x square equals to mu naught epsilon naught dou square dy by dou t square. Substitute the value, then minus omega square mu naught epsilon naught dy is equals to mu naught epsilon naught minus omega square dy equals to minus omega square mu naught epsilon naught ey. Hence ey equals to sine omega t plus beta x is the solution for this equation. Now for our wave equation, these are the four solutions, and let ey equals to cos omega t minus beta x. Now differentiating with respect to x, then dou ey by dou x equals to cos, we are doing the cos, so it will be sine omega t minus beta x. So x is there, so minus beta. Then again differentiating with respect to x, then dou square ey by dou x square equals to minus beta square cos omega t minus beta x. So minus of minus will be getting again positive. The cos omega t minus beta x is nothing but ey. Beta square ey. Substitute the value of beta square, that is omega square mu naught epsilon naught ey. Differentiating with respect to t, dou eb by dou t equals to sine omega t minus beta x. So with respect to t, so omega. Now again differentiating with respect to t, dou square ey by dou t square equals to omega square cos omega t minus beta x. So cos omega t minus beta x is nothing but ey. Substituting these values in the wave equation, omega square mu naught epsilon naught ey equals to mu naught epsilon naught, and this value dou square ey by dt dou t square is omega square ey. Hence ey equals to cos omega t minus beta x is the solution for the wave equation. Similarly, you can prove these two are also solutions for the wave equation.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.